Okay, so let's get going. I know that probably many of you are preparing for the exam too. So worked out pretty well. We had like some review from last class, but also I think I'm going to do some for this class too, because it turns out that I actually have more time for the Excel sheets than I thought I had. So I actually can cover the Excel for the pivot tables and whatnot for today, in addition to doing some review for the class, for the exam, I should say. Okay, so here's where we are right now. We're at July 5th. And you can see we have pivot tables, Excel tables, which I showed you some of the Excel tables from the last week, the last lecture. We also had the what if analysis. We have social implications of IT, which I think I'm going to try to push that off into next week. So focus more on the spreadsheets for today and also review for the exam too. Okay, so the exam two, I put the announcement out there. So you have the information there. You can join my WebEx. So same as last time, you join at 6:30. The exam will kick off. If there's any issues, you have the links for the TAs. They'll be proctoring the exam also. So if there's any issues there, you can just hop right in there, let them know as soon as possible, so we can log it and try to deal with it. So this is what I posted here for exam two. Okay, and you notice I also posted some sample question answers for the exam. Here's my WebEx information. Here's everybody else, the TAs, their links here. This talks a little bit about like how the exam is going to be broken down. Same thing as last time. So you have to click next for each question. Don't do the tabs. There'll also be the honor code question at the end. So it says 25 questions. It's really more like 24 questions. The 25th is just a check off to say that you have to acknowledge the honor code. Okay, so that's where the exam is at. Let me, so here, is there a way we can see the sample exam questions without the answers? Okay, I can try and get that out to you. Let me see. So here's the exam two. Now, probably the one area which I kind of noticed that a lot of people were having issues with for the assignment still. I mean, we have a whole bunch of examples. So if I went to here and I went down into the resources, you can see so we have flowchart examples, pseudocode examples here. These should give you a pretty good idea, but it seems like we still have some problems there. So I'm going to kind of go through that with another example from the sample questions on the exam, just so that people can get the idea of like how you're supposed to structure flowcharts. And also what I've done for the July 5th week, you'll see I got a number of like JavaScript reviews. So you remember I was talking about variable scoping, which I'll do another demo of that today. You know, review of your arrays and your loops, functions, another array review, global versus local variable review, which is the same thing as variable scoping, another loops review. So there's a whole bunch of stuff that I've kind of put out there to help you kind of prepare. This exam really is mostly about JavaScript. You know, there's a bit about the upfront stuff in terms of coming up with the flowchart, coming up with the pseudocode, but ultimately there's going to be a lot of things focused around JavaScript. Okay, so I put all these out here. So if you haven't gotten it from the previous lectures or you haven't gotten it from the recitations, there's another go at it here. And then all this stuff down here is just a breakdown of the different areas of Excel that I have here. Okay, so all of this is available. You should take a look at it if you're having a problem with any of these areas. Okay, so here, and let me see here. So here, let's go into the flow chart. Okay, so we have the flow chart here. We have to guess. Well, first we have to create the number between 1 and 100, and then we have to guess a number, right, between 1 and 100, and then we compare the guess versus the actual random number that was generated. If it equals, then great, you've guessed the number. So you're going to display congratulations, right? If you didn't guess it, either the number is lower or higher than the number, right? So if your guess is lower, then you're going to say, well, the guess is too low. If the guess is too high, then it would display a message say the guess is too high. So here is what that flow chart would probably look like, right? You know, with the flow charts, there could be like a degree of latitude where you can kind of go more granular. So this kind of, you know, is reasonable granularity, but, you know, some people kind of go extremely granular on it. Not that you're really going to get points deducted for it, but it's kind of overkill, right? So for example, you know, if you go in here and you say, I'm going to declare some variables, I'm going to do this, I'm going to do that. It's not really necessary for the level that you're looking at with the flow chart. Okay, but if you do it, it's not like you're going to get points taken off for it, so it's fine, right? But I think this level here is reasonable level. You're basically talking to people. Flowchart is more for people to understand your logic, right? It's not really for the computer to do anything with. And kind of similar for pseudocode. Pseudocode is just one step closer towards the programming logic that you're going to actually use, but it's still really more for human benefit. Okay, so I noticed a lot of people forgot to put start and end, right? That's kind of almost like a trivial step, right? So whatever you're going to do, just remember the oval and then remember the start and the stop, right? That's pretty basic there. And then you remember, like, what does a rectangle do and what does the parallelogram do, right? So the rectangle is basically for you to, or actually I should say the computer, to do something, right? The computer in this case is going to generate a random number, right? So you remember, and I'm going to actually demonstrate this for you in the JavaScript. It can generate a random number with, you know, the math function. Okay, so the computer's doing some work. It might be trivial work, but it's doing some work, right? So that's what the rectangle for. The rectangle is for like the computer doing something. The computer is doing a calculation usually. Okay. Now here, you're gonna, this is kind of where, you know, you can kind of say this is maybe an extra step that, you know, for a flow chart, I don't know if I would really care whether you put this in here or not. What's more important is the input guess, right? So this one is saying output, enter a guess, means like display on the screen, enter a guess, which is true. You do actually have to put something on the screen to tell someone to enter a guess, right? But, you know, that's neither here or there. I kind of don't really care whether you put this in here. You put it in here, it doesn't hurt. It's more explicit. It's more clear. So that's fine. But you're not going to get points taken off for it if you don't put this one here. What's more important is just input guess, right? You need some way to give your computer algorithm or your computer code your guess, right? You have to put in a number. So you guess a number. Let's say you guess 50 or something like that. So you take in a number here. Now, remember the diamond, right? And the key thing about the diamond is it takes in one input and you have two outputs and only two outputs. Do not put more than two outputs, right? So, and it could be any type of binary type of thing, right? It could be true, false, which is what this is showing here. It could be yes, no, right? It could be black, white, whatever, right? Like, as long as the output is going to be two things, you know, that's fine, right? For example, for this recent assignment that the class worked on, you could have said, you know, your two options are win or Bellagio, right? It's two things, it's two states, right? As long as you can guarantee it's going to be two states, that's great, okay? Right, in this case, we're saying, is the guess equal to the random number? So it could only be correct, right? Or false, right? Or incorrect, right? True, false, correct, incorrect, right? So in this case, we're saying false and true. Okay, so the easy case if it's true, right? So I guessed the right number, right? And then you're going to come down here. Again, you have a parallelogram and your output is going to say congratulations, right? This says congratulations. I probably say congratulations, you guessed the right number or something like that, right? And then don't forget, even though you just output the congratulations, it's not over yet. You need to follow this all the way down to the bottom and notice how it comes together to like this little circle or this little dot here. And then it comes to the stop, like so, okay? So this is like one path. This is the easiest path when you guess the right number. Now, if you didn't guess the right number, then it's one of two choices. Either your guess is too high or your guess is too low, right? And so here, you're trying to say, so you can kind of get like two outputs from it, knowing that one choice is already gone, right? The guess, where the guess is equal to the random number, that already went over to here. So that means when I check, is the guess less than random number? It's either less than the random number or it's more than a random number. It cannot be equal to the random number because you already made that check up here. Okay. And then so you come down to here, and if it's false, right, that means the number is too high. That means your guess is greater than the random number. So that means you're saying on your output, the guess is too high. Now, if it's true, which is this side, if it's true, that means your guess is less than the random number. That means your guess is too low, right? And so then you come all the way down to here, and then you come out to the stop, okay? So just from a convention standpoint, it would be better if you kind of brought them all to this circle here and then went to the stop with just the one arrow going into the stop like so, okay? So it kind of flows a bit nicer like this, just from a convention standpoint, okay? Now, this was kind of just from the example like this, right? Typically, what would actually happen is it would allow you to guess that number again, right? And so instead of having all of this come down to here, if your guess was too high or too low, it would come all, you would have these two arrows come together, and then it would go all the way back up to the top, and then it would come back to here where you're inputting a guess. Now you're going to input a different guess. I mean, nothing is stopping you from inputting the same guess, but you probably want to put in a different guess, right? Based on whether you said it was too high or too low, okay? And then it would cascade back down again, okay? Yeah, so yeah, you can use yes, no, true, false, right? Whichever one like makes sense based on the question that you're asking, right? Like I said, from the homework assignment, you know there's only two hotel options, right? It was either the Bellagio or the Wynn, right? So anything where the answer is going to be like two answers, two possible answers, that's binary, right? And so that's how you structure it, right? Now, there were people that were saying, well, what happens if there's three choices, right? So if there's three choices, you have to ask the question, like whichever is the first one, right? If it answers like true to the first one, then fine, then it's true. And then it goes out to here, right? If it's false, then it comes out to here, right? So if you think about it, this question that they're asking for your number guess, it's really three choices, actually, right? The one choice is you guessed the right number. That's choice number one. Choice number two is you guessed too low. Choice number three is you guessed too high, right? So this is a way to break up the question from being three answers into two, right? So you ask the one question here, and then it goes off on this separate branch. And then here, it would ask this other question, right? So when people are confused, they kind of say, how do I deal with, when you tell me the diamond only has two answers. Well, how do you address when you have three answers? This is how you do it. You break it up like this, and you have the one question coming down here, the answer coming down here. And then if it's not this one, it goes to ask this question about the other two. Okay. All right. I think I have a question from Arman.
Professor, what does that little circle before the stop sign represent? Is it important, or could we just leave it as a little box kind of displaying what the answer may be?
Yeah, I mean, just from like the person that drew this flow chart thing, I think their drawing program only had like circles probably. Usually what I would draw it as like an intersection, and I would draw it as like a small dot, like a circle, like a darkened circle. So this is only just to prevent you to have like 3 different arrows pointing at the stop here. So from a programming standpoint, it kind of allows you to finish up your logic cleanly before you get to the end here, right? So it's just a way of managing the different states or the different answers that come from the different questions, you know, to kind of wrap it up. So what happens is like when you do testing for your code, right? It's almost like you have this list of different questions and different answers that come out, and you know, for you to basically automatically test all of those, it's nice to kind of have them all wrapped up without going it just kind of falls off a cliff, right? You just kind of ask these different questions and then just kind of lets it go. You know, from a code standpoint, it's kind of nice to organize it into like a nice clean box. So, you know, I don't really want to go into syntax because it's not important for this class, but there will be typically something like a block of like case statements. So this case, this case, this case, this case, and then it's all like into like a rectangle or a big box. And then people can test each of those cases to make sure your logic is good, right? So, you know, without going into too much complexity about this, I'm just saying it's nice for you to wrap all of this up. In this case, they drew like a circle here, and I think it's just kind of a limitation of whatever drawing program they were using. I probably would have used like a darkened circle here, right? But the main point is wrap up your logic and then go to the stop here. Okay.
You got it. Thank you.
All right, cool. All right. So this is like a flowchart example. I'll see if I can find some more other flowcharts, but really this whole diamond logic thing where you have 3 answers and you kind of break it up like this. This is kind of a common pattern within flowcharts, right? So if you ask me, what do you have to remember from flowcharts? Number 1, remember these ovals, right? Remember your rectangle means you're processing, you're calculating something. Your parallelograms are displaying or inputting something, right? So this is displaying enter a guess. This is inputting your guess, right? And then remember your diamonds, and remember you can only have 2 outputs for your diamonds. In this case, we're saying true, false, okay? So try to remember all that, because I kind of noticed there was a number of problems with flowcharts in like various people's submissions for assignments, okay? So pay attention to that. You know, I'll just quickly go through this. You know, like I mentioned before, what are valid variables, okay? I hope this is like, hopefully this should be like a very quick, easy thing for you, right? You should be able to look at it pretty quickly and kind of say, you know, what's a valid variable for these, okay? I'm going to review this in a second. This is like for your comparison. This is the main thing, right? The if statement here, right? And I think someone here asked me, can I do a nested if statement, which I will do that, okay? You remember your math function here, which again, I'm going to do the math function. I'm going to demonstrate with the random number and the floor. Just give me a second. Yeah, so you got your math functions. You know, we've used the document right a few times here. Remember this thing, right? So this is and, right? So similar to when you're doing your web queries, both sides have to be true, right? So this side has to be true, and this side has to be true. That's why you use the and, right? If I was doing the or, then it would be like those 2 vertical lines, right? And then the or means one side or the other one is true, okay? And then don't forget, we also have the not, which is the exclamation mark, okay? So while my eye is on here, I'll just talk to this one. So when defining a variable, you must also initialize it on the same line. No, that's not true. So you could just declare a variable and then worry about stuffing something into the variable later on, right? Or you could do on the same line, either one. That's really up to you. I think it's good practice, good programming practice, but it's not like you're locked in stone to do that. Good programming practice to declare your variable and to initialize it. You could set it to 0, you can set it to blank or whatever. So you don't get into this weird thing where, later on, before you have a chance to initialize it, maybe someone else tries to read that variable and you don't know what's inside that variable because no one's put anything into it yet. So I think it's good programming practice, but nothing forces you to do that. Okay, so that's why this is false here. Okay, so you do not have to initialize at the same time you declare it. Okay, all right, so let me come over to here. Let's do some more review here. Okay, so again, I noticed a number of people has some issues. 1 equals and 2 equals. Okay, so 1 equals means I'm assigning something, right? So in this case, I'm saying n equals to 9 and x equals to n times n, which is 9 times 9, right? Double equals means I'm comparing something, right? This is like super important, and I'm going to show you why that makes a big difference here, okay? So if you look at my code, what did I do here? So I said, if x equals to 91, which it's not, right? N times n is obviously 81, right? So when I did this x equals to 91, if I'm looking at this logic very quickly, I'm thinking, yeah, okay, what's wrong here? Why am I checking this as 91? It's obviously 81, right? So no way it's going to get to here, all right? But I'm going to show you in a second. It does do that, right? So you look over here, I ran the code and it ran. Why is that? Because when I do an assignment, no matter what I put in here, right? I could put in like 101, right? Assignment will always evaluate to true, okay? And that's not really what you want, right? This is a bad thing, right? But really what compounds it, what makes it even worse is not only did you not compare when you thought you were going to go compare, you actually made it 81, 91, I should say, 91. Okay. So down here, if you didn't have this assignment here, then when I did this check for x equals to 81, that should be valid, right? Because 9 times 9 is 81. But what happens is when I did this comparison, which I thought I was only doing comparison, I was actually doing an assignment. Now x has become 91, right? So when I did this x equals to 81, which should evaluate the true, I end up never getting here, okay? And so therefore I had to reset it. Now I had to say x equals to n times n again. And now when I do the check, x equals to 81, then I have a good result of n times n, okay? And just so you guys can see I'm running it, right? So I'm gonna run this code. And you see what happens here. Bad result, right? 91, not good, right? This is because I did the x equals to 91. Okay, now when I came over to here, I'm expecting to see this, but I didn't, right? I never got here, okay? And that's because I did this assignment here. Now I have reset it. And then when I came down to here, this is true. Now it is 81. And now I got the good result here. Okay, so I hope everyone can see this example. I hope it's pretty clear the difference between a single equal sign and a double equal sign. I saw like a lot of people on the assignments doing a single equal sign for their comparison, which would totally screw up your logic, exactly like the way it did here. Okay, so this is important, all right? This will be on your exam. So make sure you understand this concept and don't mess up your equals. There's a big difference between a single equal and a double equal, okay? Now, there was a couple other questions people were asking me about. It's like, well, don't we, so we were doing the math, if you remember, we were doing the math.random, which is a number between 0 and 1, right? Not quite 1, it's like 0.99, whatever, right? And then you have the floor function, which the floor function always brings it down to, it basically rounds down, right? It brings it down to the lowest integer, for that number, right? And so that gives us like a number between 0 and 9. Right, but it's very often that we're actually looking for a number between 1 and 10, let's say. And so people were asking me, how do I do that? Well, this is what you have to do. You just have to add a 1 to it. So in this case, the output from this part is 0 to 9. If you want to really say what's the random number between 1 and 10, then you just have to shift it, right? You should use a +1 and you will shift it over. Okay. And so that's how I can get my random number here. So I'll just keep on hitting this a few times and you can see the number goes from 1 to 10. Okay. So that's all of this right here, right? You can see I'm moving the number from 1 to 10 here. So just understand how these different things, and you see how I nested this, right? Like I've done before in the other week, right? You did the math here, and then the math floor. Yes, the math floor will round it down, okay? And if you want to really get it from 1 to 10, then just do a +1 at the end of it, okay? All right, cool. And so the other thing I wanted to hit on while I'm here is this idea of variable scoping, okay? Now, I know again on the assignment, people were trying to figure out how do I kind of essentially store or carry variables around. And so what I was saying is, let's pretend down here, this is like what you were doing, right? And when I declare, like in my body, if I declare like this script, right, I put these script tags here and I put a variable here, I've essentially declared a global variable. So in this case, I said var test me equals to ABC. Okay, so what do I mean by global variable? That means when I do my JavaScript, remember when I said JavaScript, it's anywhere with these on clicks, right? And I have these double quotes here, right? So I created a button, right? And then you have the on click, and then you have to show random number, and then you have the alert test me, right? So I'm just going to show the variable ABC, okay? So let me just run this for the sake of it. And then just quick thing here, you can see the function that I'm calling, show random number. I did the alert for test me here, right? I called the math random function, and then I just displayed the random number. So let's see what happens, okay? So I'm going to hit generate random number. And so right here where it says ABC, that's this right here, okay? So you can see I declared and initialized a variable called ABC, which is now a global variable, okay? Now I go in here, right? And the button, right? The button, the on click, it can see this variable, which I'll show you in a second. It calls this function. Within this function, I can see test me, right? That's how I know it's a global variable, right? No other place am I declaring this test me, right? Except right over here, right? Where this script is. And then it displayed it, ABC. Now I'm going to display the random number, and then I'm going to come back out from the function. I'm going to end up over here, and I'm going to have ABC again. So ABC all the way through, global variable, right? Now, what happens in this function here if I declare another variable, test me equals to XYZ, okay? What I've done is people, and this is actually really not good programming practice, but again, you can do it, right? So I'm here, you can see test me here, and I've essentially created another version of this variable, test me, okay? And I'm going to demonstrate that right now. So I'm going to run this. Now you can see XYZ when I'm here, right? Alert test me, it shows me this variable test me is now XYZ, okay? So within like this function, anytime I refer to test me, I'm showing XYZ, okay? Now, when I come back out of this function, come back out, it's ABC, okay? So inside the world of this global area here, your variable test me equals to ABC, but inside this function, test me, because I declared a new version of test me here, is XYZ, okay? So this is what we mean by variable scoping, okay? Within this function, you have like this, basically this separate world where that variable is XYZ. When you come back out, this variable doesn't come back with it, right? This just gets destroyed. This function is gone, right? And it comes back out to here and you revert back to ABC, which is what you declare globally. Okay. So that's why I kind of demonstrated this. So this to me, hopefully is a clear example of variable scoping. Okay. All right. Does anybody have any questions on this? Cool. All right. Now, I think one other thing someone asked me to demonstrate was a nested if else. So let me come back to my if statement here. So there's a couple of things I can do, right? Once I get into like this variable block here, right? So these curly brackets mean like you're like a block of code essentially, right? I can do something like this. I can do another if statement in here. And just to be stupid, I'm just going to do another check. Is x equals to 81, right? I can easily check anything else, doesn't matter. Okay. And I'm just going to quickly do this. People can't see my keystrokes, but I'm just doing Control C, Control V to copy paste. It's a common thing to really get a lot of code cranked out pretty quickly. So let me run this. Well, let me do a BR so it doesn't get too messy. And let me run this. All right, so here you go. We got a nested if, which of course, right? Because I'm doing the same check, right? X equals to 81, X equals to 81. Okay, so this is a nested if. Okay, now I can do, there's a couple of things I can do, but let me, for the sake of argument, let's do an else, right? And I'm going to say nested if else. Okay, so what happens is, of course, this is going to evaluate to false, right? Because I already know that x is equal to 81. So this is going to be false. Therefore, it's going to come out to this else statement here. Okay, so let me run that. And there you go. It's a nested if else, which is what I printed here. Okay, so the main thing here is you see how I have all these tabs. I kind of tab these. If you don't do this and your code editor doesn't really highlight your blocks for you, this can get really confusing in a really short period of time. So, you know, I kind of do this tabbing here so I can kind of tell where my curly brackets are relative to the block, right? So in this case, I have this here and this here, right? Now, this JSDO is not like, you know, Notepad++ or whatever, so you can't really see. And even in some of the editors, it'll, when I click on this, it'll just show, it'll just highlight all the curly brackets, which doesn't help you that much, okay? But in some cases, some editors will kind of show you which curly brackets pair up with the other curly brackets, so that could be helpful. So without all of that, I kind of have to do this tabbing here. Otherwise, like I said, it gets really confusing, okay? And the other thing that's a convention, not everybody does it. Some people put the curly bracket into the next line, but I think generally these days, a common convention is to put the curly bracket to start off your code block right after your if statement. So here's your if statement here, and then I do my curly bracket here, and then I can do the rest of my logic, and then I close off the bracket. Okay, so in this case, here's this curly bracket, and here's this curly bracket. Now, when I did the else, you can see I put the curly bracket to start off right after the else statement, and then I close it off here. Okay, so hopefully that gives you like an example like of a nested, both a nested if statement and a nested if else statement. Okay, main thing is the gotcha there. Keep the brackets, the tabbing and everything in nice order. Otherwise, you're going to have a heck of a time trying to debug it if there's a bug in there. Okay. All right, cool. All right. I've kind of gone a half hour through this, and I'm going to I do need to catch up on the Excel stuff, and I do need to kick off some of the other stuff for the remainder of the stuff that you're going to pick up for your final exam. But hopefully this was like a decent catch up or review of any of the open items that you might want to watch out for the exam 2 that's coming up on Wednesday. Okay. So so for the document, right, if you want more spaces, well, I mean, so for the document, right, so kind of like what you have here is what you're gonna get, right? So let me come up to here just very quickly. Document, right? So I can put it something like that, right? And I can run it. Oops. Oh, actually, my fault. I said it right at the very beginning. You need for HTML, you can't just put spaces in there. So my fault. So you basically, let's say if you want to do like another paragraph or something, or you want to put in like a non-breaking space, you kind of have to put in actual HTML in there. So if you want to put in like a P or so and if I want to do a and test like that. So I have the new paragraph and I also have like a break here. So that kind of created a couple lines here after the 91. Okay. Yes, so anything inside the parentheses, or actually I should say the double quotes, is your HTML. Okay. So these parentheses basically mean like a function call, right? And then this, like with the quotes, essentially is your string, right? So I could have done something like this. Var test string equals to this, right? Let's do that. Here, okay, and then I can do something like this. I can take this out and I can put test string. Okay. You can't really tell that I did anything here. Well, how about new test here? Okay, so you got the new test here, right? So just like we have the math function, right? You have these open parens. So anything with a function call obviously is going to be in this type of format. You have the function name, and then you have like these parentheses for your parameters. So in this case, I'm passing in test string into here. So I can put in all my HTML in here, assign it to a variable, and then pass that variable into this function. Okay. All right. So hopefully I didn't confuse anybody there, but that's how the document write would work, right? But all of this would be your HTML. Okay. All right, cool. So let's get back to spreadsheets quickly. So where are we at here? That's it. Here we go. All right. And so I did a bit of the conditional formatting last time. Okay. And we did the what if analysis. And then I think we got to the table here. And we had the if statement. So let me go to the sheet that I set up here. And yeah, I didn't forget. I will make a note to try to put up some more flowchart examples onto the resources. So I'll do more flowchart example as well as some pseudocode examples. But if there's other examples you'd like me to put up there, just shoot me an email and I'll see if I can find something for you. But like I said, most of the stuff is what I just reviewed. Hopefully that kind of gives you a good idea of things. Okay, so I got a couple of things set up here. I went through all of the stuff on here, which I also posted up onto resources for the slides here. So I think I can just be able to talk through all of these here in here. All right. So what I do, I set up a little table here. This is a table. Like if I went into here, you can see we have pivot table and then we have table here. Right. So this is already done. I already set this up as a table, but I'm going to do a pivot table off of this in a little bit. Okay. And so what did I do? Well, I have like basically a table of employees, which is kind of common, right? So you have like people with their first name, last name, what region they're in. So region here would be Europe, North America, or Asia. And then I have cities here. And then I have some building names here. And then I have like whether the person is a consultant or employee. And then the length of service, right? And then let's say the ranking, right? So of course, this is a very small table. Normally, you'll probably have hundreds and hundreds of these, right? But I'm doing this just to kind of talk you through it, okay? So I believe last time I told you can do something like this, right? So I defined the table name and then where am I at here? Where's my table? Here we go. Here's the table, right? So you can do, I added the totals row here, okay? And so this is like the totals row here. And what you get from here is this idea of subtotal, okay? And again, I believe a lot of you I've seen this from the last lecture, but I'm just gonna quickly touch on it again. So one quick thing, there's two things to note if I look at this. One, you can see this is a range, right? Now I could have done like, what is this? I2 colon to I9, and that would be the range, right? But once I create this table, the Excel is smart enough to kind of actually name this. This is called like a named range, okay? So in this case, instead of saying I2 to I9, which no one looking at it is going to know what the heck that means, right? But if I tell you, oh, this is your rank range, then people can kind of say, oh, here's rank, and that must be in this range here, okay? Now that has some good things and bad things to it. On the one hand, when I look at this and I see rank, I'm going to be thinking this, so it's a lot easier for me to associate that range. But alternative, I made a mistake. If I did rank and for some reason I defined the rank to be I2 to be I8, you're never going to know that. You're going to look at rank and you're just going to assume that rank must cover all of this, but it doesn't necessarily need to, right? You're just assuming that Excel did this all automatically for you and that it works, right? But I've seen instances where it doesn't work, right? So you're looking at it, you're pulling your hair out wondering, why is this not working, right? So the rank here, you're thinking it should be this, but it's not always going to be the case, right? But I'll just assume that Excel got it right. So that they call this rank. And so when I refer to it as rank, then it's nice and easy. It's almost like I'm looking at this and say, oh yeah, they must be looking at this as rank. Same thing when I look here, length of service. Length of service is basically the name range here, okay? And you can see here, I kind of created like this employee table here. So you can see your named, I guess your name table here, right? I did another table one, but don't have to worry about that right now. Now, I mentioned this last class, this subtotal and this function, of course, 109, you don't know what that means, right? So I'm just gonna go in here really quickly. And you can see all this. And you're saying, well, what's the difference, right? So you remember, like anything from this 101 and on, this means that it will do the calculation based on what you see. Like if I filter some stuff out, then it's not going to get picked up, right? Versus like the standard Excel function will pick up everything, regardless of whether you can see it or filter it out, okay? And I believe I demonstrated this, but I'll demonstrate it again. So 109, so they refer to it as 109 instead of saying sum. Okay, I'm not sure which is easier, but I guess that's the way Excel works, right? So it's 109 and it's like that, okay? So when I look at it, I just see 109 length of service, and you just kind of have to know that means subtotal for your sum where you have to filter. Now let me do like the regular sum here and sum that. And you can see when I did the highlight of that range, it says length of service. So it kind of figured that out for me. So in this way, you can be sure that the range lines up with those individual rows that I highlighted there. So that's a good check, right? But if I just typed in like that range directly, and then I came back to it later, you may or may not know what that range actually covers, okay? Cover, so it's 62, which is good. All right, now let me do a filter here. Doesn't matter, I guess. Let me take out just for EMEA. Okay, so look what happened here. This still stayed at 62, but the subtotal came out to 28, which is correct, right? So, well, the definition of which is correct depends on what you're looking for, right? If you're looking for what is the sum of people with their length of service based on their region being EMEA, well, then this is correct. But if you're looking for the sum of all of your employees' length of service, no matter what, then this is correct. Okay, so in the context of the table, most likely you care about this. Okay, so keep that in mind. This is important, right? Make sure you remember that if I do filtering and I want the numbers like my sum, let's say, or my average to filter to be based off of that filter, then you need to use the subtotal, right? Which basically is like the 10, like anything that's 101 or greater, right? So if I'm here, these are the standard ones here, and all of these are basically allowing you to do the filters, okay? So let me get off of that for now. Let me go into like a pivot table, okay? So a pivot table basically allows you to kind of like organize your data, almost sort of like a way for you to kind of slice and dice it a bit, right? You can kind of do it here because you just have these standard filters here. You can do sorting and whatnot. You can see the sorts up here, right? But let me show you what you can do with a pivot table. So I select one row, one cell, I should say, and then I go into here, right? Here's the insert, and I go into pivot table here. And here, okay? And so now I can just select on any of these things here, and then I can apply to these different things here, which I'll kind of go through what they are. So generally when you're working with a pivot table, you're working at a high level. You're kind of working at what we call the aggregate level. You're kind of maybe working your way from the top down, right? So what that means is you're probably not going to select employee ID, right? Employee ID is basically identifying one particular record, right? You actually want to look at groups of records organized by whatever groupings. So what's a grouping? Well, a grouping here could be like a region. So let me click on region, and I actually want to, let me do the region here. And then let me do the city, like maybe over here. And I want the city to kind of come across this way. And then maybe even within the city, we might have multiple buildings. So let's maybe put a building here. Okay, now maybe things are treated differently, whether like someone is a consultant or an employee. So maybe I want to do this, but maybe I want to do this as a filter, like so. So, and then let me see what my length of service would be. So that's what the summation here is. This would be your length of service. Okay. I'm not liking the way this is organized here. So let me drag this back down to here. I'll put this down to here, and I'm going to put the region over to the columns here. All right, this might be a little bit better. Okay, obviously it's a small table. So normally like in a particular place, I might have like, you know, multiple cities and whatnot, multiple buildings. I'm going to put the city on top. I like the city on top better. All right, so you have your city up here and then you have buildings here. Okay, now normally, you know, within a particular region, you probably would have multiple cities also here. So here, I have my filter. Remember, I put in my filter as a type here. Okay, so let's say I want to filter out only by employees. All right, so what is this telling me here? Let me just put this here so you can see the filters here. So what does this tell me here? So I'm here for the employees, let's say in the Asia region, right? The Asia region has Hong Kong and Mumbai. And I have some buildings here, only one building each city, which, you know, like I said, we have more data in here. We'd actually have multiple buildings in here probably. But we have like 12 employees. I shouldn't say employees, length of service, right? We have 12 years length of service for the employees there. And then we have 8 years length of service here for the people in Mumbai. Okay, now we have grand total, which is all the way at the bottom here. Oops, get that sucker out of there. So, and then same thing for EMEA, right? In EMEA, we have 2 buildings in London, right? And then we have the length of service here, length of service here. And then in North America, we have New York and a building in New York, length of service there. So you can sum it up by region, right? Here's your numbers going by region. So that's up and down here. And then across, going this way, you can go across too. If you happen to have some overlap, which I guess you wouldn't in this case, right? So it's more like kind of going up and down this way. And then your total would be here. Okay. So you can play around with these different things here, and you know, but this seems to make the most sense to me, right? So you basically have a database of employees and you're organizing them by region, by city, and by building. And then I just put like a filter in here for whether it's a consultant or an employee. Okay. Now, what else can you do here? Well, let me see here. Typical stuff here, formatting, show details, pivot table options. We do this. And let's see if, let's see how our chart looks like from this. Okay. All right, this looks reasonably well organized, right? So you have your different cities here, right? So this is Hong Kong, this is London, Mumbai, and New York. And then basically all of these columns here is your sum of your length of service. So this is how many years your employees have been working for you, right? They're color coded by region, right? So the blue is for Asia orange for EMEA, and gray is for North America. Okay, and you can see here, I can even do some filtering. Let's say I only want to see Hong Kong and Mumbai. I can do that. Let's say I'm going to do CW and HA. So I'm going to take out these buildings like so. Okay, so you get like some filtering action here, kind of like dynamic charts here. Okay. The type here, that's still the employee versus consultant. So let's do the consultant here, just like so. Okay. So some people might like these charts. These charts maybe seem more, you can grasp it a little bit better than just looking at the pivot table here. So that's really kind of a preference here. Okay, so this is all about pivots. In this case, you have like your pivot charts here. Okay, and like I said, it's kind of pretty straightforward. You just select your table and you can pick the fields and you can put them onto like the rows or the columns. You can select different filters on here. Then you can put in like the summations. Usually it's a sum, but it could be an average, it could be whatever, right? The typical statistical functions in Excel. And then you can also create like a chart off of it too. And the charts also have filters on it too. Okay, all right. So let me see here. Oh yeah, I think before, I forgot whether I covered this before, but I thought I did. We also had the idea of concatenation, and then we also had like the if here. Okay, so I'm just going to do like a quick walkthrough here. So this says like sheet one. It just happens we're on sheet one already, so it's kind of like you don't really need it. But if you're kind of looking at multiple sheets, let's say for the sake of argument, this table was like over here in another sheet, right? And then you're kind of trying to do this and you want to access it, you would call it by that sheet. So if I want to access from here to anything on here, it would be like sheet 4. Okay. In this case, I'm not really doing that because this sheet 4 is already generated from sheet 1. So I'm kind of like making a circle if I do that. So you don't want to do that. But anyway, this is just like kind of like longhand notation. You don't really need this sheet 1. You can just say G2. Okay. So in this case, I'm saying G2 here, and you can see it kind of highlights with this little box here, right? And you're going to check, is it an employee, right? If it's an employee, then the value is true, else it's going to be false, right? Right. So in this case, it's false, right? Because this is a consultant. Likewise, this is true because this is an employee, right? So on and so forth. You work all your way down, right? Remember what I was saying here? This is your fill when I drag this, right? So I can drag this down and it just takes that formula down. Let me just empty this out so you can see what I just did here. So I do a clear. That's the formula. I do the click on the bottom left here, pull it down, and that's called a fill, right? So it just kind of takes my formula and pulls it down to here. Okay. And this is checking if it's a London employee. And just another check, right? But this one I'm using the not. Okay. So all that means is that I'm doing that check here for its employee, which is the same thing as what I was doing over here, but I'm flipping it around with the not here. Okay, so with the not, then if it's true or false, it'll show like that. Okay, so these are all true falses here. And then here's a demonstration of concat, right? Concat is the short for concatenation. Okay. And so all I'm doing is taking E2. This is E2 right here. And I'm putting in like a little dash. And then I'm taking in F2, which is here, F2. And so the end result is I have the city dash the building. All right, so that's what this concatenation function is. Okay, so if you kind of step back and look at what you kind of covered in this class, you covered how to do concatenation within JavaScript, and then you kind of have the analogy here, right, for your Excel. And likewise, you kind of did stuff with mod or exponents and whatever. So almost anything that you're doing mathematically within JavaScript, there's like some sort of equivalent within Excel. So we just kind of hit those here, right? Same thing when you're doing your ands, your ors. You know, there's almost like a straight one-for-one analogy between Excel and JavaScript. So once you start kind of studying it, you just kind of think about, oh, you know, this is how I was doing it before in JavaScript. How do I do it in Excel? Okay. Let me see here. I'm going to come back to here. We did the subtotal. So this one just lists all of it. Okay. And so I refer to as filter. They call it include hidden, ignore hidden. Okay. Here, return. So logical function, right? So this is and or not, which we just went over this for JavaScript also. So you can do this inside of ifs. You probably don't want to nest this too much. It can get pretty tricky to debug this. This is harder than JavaScript when you do the nesting. It gets kind of confusing. But yeah, like I was mentioning before, it's similar to the JavaScript equivalents. Okay. And yeah, you process it from left to right, right? Unless you stick some parentheses in there. Okay. So this is a demonstration with the and. So here's the and right here. So what's the and looking at? The and is looking at is B5 greater than 75 and is B5 greater less than 95. Okay. And then if this evaluates to true, then it's going to say approved. If it evaluates to false, then it'll be denied. Okay. The dollar, so the dollar, okay. So I think here, okay. So there's a couple of things here, right? Here, like I was saying, you don't really need to have this sheet 1 here. It's only because it was kind of more written in a generic way. Like I said, if they were referring to sheet 4, you would see sheet 4 here, okay? So the sheet is basically specifying which one of these tabs you're referring to here. And then the syntax is to include with the exclamation mark here, like so. Okay, so let's see what happens if I take this out here. Oh, actually, I should take this out too. I can take this out too. Like that, right? Still works, okay? So it's just, I hope people are not getting confused by it. It's just, like I said, it's just referring to the sheet here, right? Let me just drag this down. I'll just replace all of it. Okay, so no more sheet reference. Okay, so when you saw like that sheet with the dot with the exclamation $, all that means is this is the sheet that you're referring to, and then you can call whatever cell you're looking at. So D2 or whatever. Okay. Yeah, so you don't need to have that sheet information in front of it, right? It's just kind of a generic way later on. If you kind of took this table and moved it to another sheet, then you can just replace that sheet on there. So that's all there is to it. Okay, I wouldn't worry too much about that. Okay, but if you happen to see it, don't get surprised by it. That's all. Okay, right? But this works. You can see that this works also without the sheet information on here. Okay. All right, so this is the and, right? So what I was saying here, here's the example of the or, right? So the or, like I said, if you look at this, is this green or is it red? Then it's okay. Otherwise, it's false. That means you have to repaint it. Okay, so only one of these has to be true. So that's exactly the way this behaves inside of JavaScript also. The not like so. So if you're testing, is B29 green, right? So where's B29 at? B29, right? Is it green? No. Okay. So it's false. But then because there's a not there, then it becomes true. Okay, so it just basically reverses it, right? So in this case, you can see this B29 is red, which is false. And then with the not, it makes it true. Okay, so it's just kind of like a flipping around. Okay, so that's why this is true here. Okay. So average if, count if, sum if, right? So you have like whatever range, your criteria. Okay. So let's say equals sum if, see if this is my criteria. What's my criteria? I don't know. Let's 62. Some range. Oops. Ah, crap. What am I doing here? Let's see. Oh, I didn't put my double quote here. Okay. So greater than 10, I should say. Greater than 10 here. Okay. And so what was greater than 10? If in this range, what was greater than 10 was 13 and 12. So that's why you have 25 here. Okay. So you have to make sure you put in your criteria within your double quotes here. Okay. While I'm here, let me do the average if equals average if. So same thing, I can do this and I can do greater than, well, let me do this. I'll do less than 10. Like that. Let me squeeze in the decimals here. Like so. Okay. So this is a sum if, and then this is an average if. So basically, whatever fulfills your criteria, then you're going to do that function on it. So in this case, if anything was greater than 10, then I'm going to do a sum on it. In this case, if anything is less than 10, I'm going to do an average, which will be these up here. Okay. So I think all of these will be working the same way. Okay. So here you have the average function, and so one extra point here would be if your criteria and whatever you're processing are different, then you can do that, right? So in this case, it's saying that anything where the bedrooms or the number of beds are greater than 1, then you're going to take an average of the prices. Okay. So let's see if I can do the same thing here. So if average here, and then let's see here, I can do this. Equals employee, then I'm going to average that like so. Okay, so what did I do? I went here, I looked for anyone who met the criteria to be employee, and then I'm going to take the average for the length of service here. So that's what this does. And then same thing for these, they all work the same way. So any of these things with like average, count if, sum if, they all work the same way. Okay. So that's average, average, count if, sum if, like so. Okay. I believe everybody should be okay with absolute and relative cell references. So, but I'm just going to reiterate that one more time. So you remember if I look at this, this is cell H2, right? And just by me saying H2, that's a relative cell reference. So if I say this, that's a relative cell reference, right? And what that means, if I do something, let's say times 2. Now, if I want to drag this down, what's it doing? It's going to change it, right? It's going to make it H3, H4, whatever, right? Because Excel is trying to be smart. It's trying to adjust your cell based on what you did, right? So I basically dragged my formula down, so it assumed that I'm going to also look at each of these going down like that. But let's say I didn't want to do that. I actually want this number to stay constant for whatever reason, right? So in this case, if I want to lock it in, if I want to lock in the H, I put in $1 in front of it. I want to lock in the 2, I put $1 in front of it, right? So they're still the same thing, right? H2, which is 4 times 2. But now when I copy this down, it stays constant at 8, okay? So you can see absolute self-reference locks it in, okay? So for example, if I was doing something where I would say tax rate and I say like 0.08, right? So this is one of those things where you might have all kinds of places around the sheet that you're going to refer to the tax rate, right? So you want to lock that in. So probably anytime you refer to D16, you're going to probably put $1 in front of it so that if someone tries to copy and paste that formula, you're not going to like get some weird behavior, like, you know, moving your columns or your rows on this, you're locking in that D16. Okay, so that's what your absolute and relative cell references mean. Okay. Yeah, so I think we covered all of these here. Okay. All right, so let's go quickly into the other one here. Okay, so this one we actually have covering for chapter 11 and 12. I'm not going to really harp on it too much. I'm going to probably review it more next week because, you know, this is really more for the final exam than it is for exam 2. But I'll just kind of run through it a little bit. Okay. So we started off here. There was more spreadsheet stuff here. So social implications of IT. Okay. I would just say maybe it's just implications of IT. I'm not really sure if there's like, yeah, I guess there's a bit of social implications to it, but it's just like how things get done, right? That's been impacted by IT, right? Or technology over recent years, right? Obviously, you know, this has been around for a while, so there's been other stuff that's kind of happened earlier on. So it's really kind of maybe talking more about since technology has crossed over into like the internet. Okay, so there's been a lot of things that have happened as computing power and connectivity has really been commonplace for everybody, right? For the masses, essentially. Okay, so this is just like, you know, some examples that you probably see in headlines and stuff like that, right? So crowdsourcing, electronic payments, intellectual property, talking about open source software, different types of copyright. How can you use certain data that's out on the internet? Okay. So crowdsourcing is this idea that you can potentially have a lot of people who will bring their expertise to the table and work together to solve a problem. Okay, and so these are some examples here. Probably most of you have some experience with Wikipedia, right? So if you do like some searches on various types of things, you know, back in the old days, people used to organize like encyclopedias and stuff like that to be the store of information, right? And so what happened is with like Wikipedia, different people with some expertise would write these articles, and then it would be reviewed. There would be like a process to take that in. So it's not like anybody can just publish whatever they want. But once you get to that review process, then basically you created a new entry, and basically this volunteer workforce has created a whole bunch of entries to basically replace the idea of encyclopedia, right? So that's what Wikipedia is all about here. Okay, just let me pull it up here. So Wikipedia. So, yeah, and almost anything you can kind of think of here, it's almost like this dynamic encyclopedia that's out there that everybody kind of contributes into. Okay, so you can kind of play around with this on your own, but the idea here is this is one of the things that have come around since the internet that has kind of displaced what used to be out there in terms of encyclopedia, right? So encyclopedia, it used to take a whole bunch of people many years to kind of keep on keeping it up to date. You had to pay a lot of money for it and whatnot. And with something like this, Wikipedia is for free. Everybody's out there contributing to it. And it's kind of like keeping fairly up to date, right? You can debate about like, you know, whether there's some like bias towards like, you know, certain groups of people who are contributing into Wikipedia and whatnot. But this is generally regarded as a success story in terms of internet and crowdsourcing. Okay. These others, like, so Linux, that's kind of like well, not kind of, it is an operating system that, you know, a lot of servers run on. Probably most of you are not running Linux, but again, it's one of those ideas of open source. You know, Apache, you know, Waze, you know, probably for those of you that drive, probably you're familiar with Waze. Some people probably use Office rather than Microsoft Office, let's say. So these are all ideas that are out there where, you know, generally, you know, it's software or knowledge that's more accessible to the common everyday person. Okay. Now the other idea is about like crowdfunding. Okay, so crowdfunding is something like, you know, you have a cause or whatever, right? So some of you may have seen like Kickstarter campaigns. There's the idea of like microfinance. So microfinance would be things like Kiva. So there might be some, you know, situation where in the old days, number one, like maybe you couldn't even get that to happen. So microfinance, like you probably would never have like a bank do that, right? Like a bank, probably they're always making loans to like bigger loans, right? Microfinance, maybe for some poor countries or whatever, it's kind of more suitable, right? It's kind of like coming from peers, like, you know, other people, not really from the banks, although banks have started to invest into some of these things. So again, it's making like financing more accessible, because without that, how did people borrow small amounts of money, right? Maybe they went to their circle of friends, which, you know, that may or may not work, right? And, you know, there's all kinds of problems with that, right? Whether it's like maybe high interest rates or, you know, how do you handle non-payment and things like that. So various areas in terms of financing, whether it's raising money for a cause or microfinance, that kind of falls under here. Okay. Then you have the idea of electronic payments. Okay. So there's one part of it where it's kind of like the money exists in the real world, right? You know, maybe it's borrowed or whatever, but it's somehow, some way, it's kind of like real currency as you might know it, right? So maybe you have a bank account or you have some quote unquote real money at one of these providers, you load it up, right? Like your Starbucks coffee or something like that, right? So that's one aspect of electronic payments. So you don't really have to carry cash around. So you have basically a cash equivalent on your phone, let's say, and then you just kind of swipe your phone and you make a payment, right? Now, the next step in this, which, you know, obviously is a little bit volatile right now, would be the idea of like basically replacing the known currencies as it is right now with an alternative, which is where something like Bitcoin kind of comes in here. Okay. So that one's a bit more volatile and there's some challenges that are going on there, but it's an area that's under development, right? So that falls all under electronic payments. Okay. So, you know, and I think that's maybe something that's come along a little bit more in recent years, especially this past year with COVID, where most people probably didn't want to be changing cash or coins with other people, right? So having electronic payments probably got accelerated a bit just in this past year. There's other countries that may be further along with electronic payments, but I think probably where the US is moving further along with electronic payments, and maybe they'll catch up in that regard because of what's happened recently with COVID. Okay. So collaboration, that's where another big thing that may have actually developed more with recent events in COVID. Okay. That's really the idea of like people working together collaboratively over the internet. Okay. Whether it's like doing stuff with Zoom, like people having meetings, or doing like you guys probably do stuff with Google Sheets and whatnot, where everybody can update at the same time, right? So everyone can work together collaboratively. They can have like video chats going. They could be sending messages to each other. So there's a lot of like potential collaboration stuff. Again, that's another area that probably has picked up in recent times, probably not really by our choice, but it happened that way in terms of like Zoom and whatnot with COVID. Okay. So what we just kind of talked about is probably what you would call some of the positive aspects of things. There's some other challenges, right? So one of the other challenges that's been highlighted is the idea of like filter bubbles. Okay. So you probably know, like, when you're doing stuff on your phone or you're doing stuff on your computer, like various things, let's say Google, right? Could be other things too, are constantly looking at your data to try to customize the experience for you, right? The whole point, everybody, quote unquote, wants a great user experience. Part of having a good user experience is whoever you're dealing with, whether it's Amazon, whether it's Google or whoever, right? They all have a certain amount of your information, right? The more information you give them, the better from their standpoint to, provide you a experience. They're almost anticipating what you want, right? They're thinking ahead because based on your past behavior, I'm going to tailor, the options for you. Okay. So some people say, "Man, that's awesome, right? That's great." But there could be some challenges there. Number one is this idea of filter bubble. The other idea is about the fact whether these companies can sell your information to other parties for reasons that you may not approve of, right? So, there's a couple of challenges there. But the first one here, let's say we're talking about filter bubbles. Okay, so what does that really mean? Let's say you like to read about cats and dogs all the time, right? Like that's your thing, right? So you're reading about cats and dogs all the time. Every day you wake up and Google serves up these news and it's all you ever want to know about cats and dogs, right? And it's just like, that's all you get, right? After a while, are there other animals? Are there other things for you to think about? Maybe, but you don't know about it because all you're getting is the information that you like, and it's like this circular type of thing, right? The more you read it, the more Google or whatever says you probably want to read more of this stuff, right? And then it will just keep on putting more, and then of course you're going to read it and just reinforce that. So it's like this circular thing. So in terms of like exposure to new ideas or just going beyond like what you typically look at, it becomes a challenge, right? Because the technology is built to keep on pushing you the stuff that you've liked in the past, right? And it, like I said, becomes this reinforcing thing. And so that's part of like what people would associate as a filter bubble, okay? So it's a challenge, right? How do we deal with that? That's open for debate, but that's one of those challenges here. Doesn't have to be news in this case. This is talking about like other types of media. Okay. This is like political type of stuff here. Okay. Have the Onion here. It was kind of interesting. There's like, some poll or whatever. I forgot what the percentages were talking about the Onion and how many people either realize or not realize, how much of the news is real or not real, right? And it was quite surprising that, some people, not some people, a lot of people did not recognize or did not know that the news satire was not real news. Okay, so that's something that's kind of a challenge, right? That's part of the technology landscape right now. Now, probably every other day, you probably hear all about like data breaches, right? Different things that you turn around, you lost all your credit card information, you got like someone impersonating you and emptying out your bank accounts. all kinds of crazy stuff, right? So that's, unfortunately, that's out there. It's constantly evolving in terms of how do we keep things secure, whether it's our data, our ID, whatever, right? So, there's a big challenge, and there's all kinds of like guidance on how you should be safe with your passwords here, right? So, these are just a couple links here. You can kind of take a look at it on your own. You probably notice a lot of times nowadays, a lot of different vendors or providers are using this idea of two-factor authentication, right? Because of some challenges within passwords. I probably think that in the longer term, we probably won't be using passwords anymore, but it's going to take a while to get to that point, I guess. But this is another area like security. How do you deal with that? How do we maintain that? And one of those key points is passwords. Okay. Okay. Phishing attacks. You probably have seen it in some form or another where, maybe your bank sends you or email, right? Saying, oh, we've had some sort of security breach. We need you to log in here to reset your password, right? Do you really know that email came from your bank or not, right? Sometimes people would do these type of phishing attacks to get your credentials, and then they'll go in and impersonate you to empty out your bank account, let's say. There's other ways that, let's say you're working for a company, someone's sending you an email from the outside, and they're trying to get your credentials so they can hack into your company, right? So a lot of times, like how you get into like a secure website or you get into a company or whatever, it's not because of like a vulnerability, on the software that they're running. It's more like there's a vulnerability of the people, right? I've seen things where, you run like these phishing attacks. There's companies that do tests on phishing attacks. They'll kind of send out these emails and see how many people will click on those emails. And basically, by you opening up the email and maybe even responding to certain things on the email, you basically make your company or make yourself vulnerable to getting hacked, right? You'd be amazed. Like we run some of these like tests on some big companies, and could be like maybe half the people will fail the phishing attack. Somehow they'll click on it, right? There'll be like some email talking about your bank account, your health benefits. Maybe in your case, they're talking about something at Rutgers or whatever, and then you'll click on it, and then like all kinds of hell breaks loose, right? They'll get your ID, or they'll download some information onto your computer. All kinds of things will happen from these phishing attacks. So there's some best practice on these to kind of manage this, but this is a pretty big problem, and it's probably led to a significant number of the data breaches that you've seen over the years. Now, the other area is intellectual property. Okay, whether it's like text, books, music, video, you can imagine like anything, as it says, information as a result of the creative process. Okay. So, people who spent the time and effort to create this want to be recognized or rewarded for that, right? So there's like a lot of challenges how to manage this effectively. It's still ongoing type of thing. So for software, there's this idea of you have your software license agreement, okay? And that's kind of like, from the early days, like pretty traditional type of stuff. You have like, I can get this, piece of software. Let's say it's Microsoft Office, right? And I can do stuff on it. I can't turn around and sell it to someone else, right? And make money for myself on it, right? So that's probably not a part of the software license agreement, right? So everything kind of like officially legit it's really basically you getting a license with Microsoft, let's say. So that's what they mean by, whether you're using it for yourself or maybe you're turning around and, doing for commercial use or redistribution of it. Okay. How many sharing or how many copies of it? Yeah, that's part of that license agreement. And then we have open licenses depending on, whatever you're dealing with. This one is an example of Firefox, right? So that leads into something called open source software. Okay. So open source software, like I mentioned before, was like Linux as an operating system, right? So Linux is something that, the basic part of it itself as an operating system is open source. People can install it. I can download it, install it on my computer if I want to. And then people may add some enhancements on top of it, and they'll come up with their variation of that. And then that's how they make their money. Okay. And then you have proprietary software, right? And like I said, I keep on coming back to Microsoft as one of those places where that's essentially proprietary software. They hire their own team of programmers, they develop the software, and then they sell it to you, and that's how they make money. Okay. So yeah, so there's different challenges here when it comes to open source, like who's paying for it, right? So I come up with a new operating system, right? How do I make money from it? Or let's say a group of us, how do we make money from it, right? So this is where, the questions come up. How do you make money if the product is publicly available? And I'll come back to the Linux example. There'll be different companies who will say, okay, here's like something that's open source, but if you just take it by itself, like a typical person is not going to be able to do much with it, right? They might be thinking, oh yeah, this is for like, a bunch of really hardcore technical people, and they can do great things with it. But for a normal person, it doesn't do me any good, right? But then if someone else comes along and says, yeah, but I'm going to offer you like, all of the software to make it run easier. So you'll have like a GUI, you'll have like, all of this stuff for you to do your personal productivity. It could be your word processor, it could be your spreadsheet or whatever. I'm going to put all this on top of it, and I'm just going to charge you like, quote unquote, a small fee to have that software. So, that's how they add value. And so that's how they make money on top of maybe this open source software. It's kind of like, open source, like enhanced, right? So whatever the basic offering is, there'll be like some people offering something advanced on top of that, and that's how they would make their money. That's an example. There's other ways to make money off of open source software, but that's kind of one that I see a lot of. Okay. So copyrights, of course, you have different, maybe papers that you wrote, your website. So, you're going to have some rights around that, right? How to make a copy of the work. If I want to take that and basically make a tweak to it, maybe I'll just kind of add a little bit of flair or flavor to it. So that's what they mean by creating a derivative work of it. And then whether I can distribute and publish that work, okay? Or publicly perform or display the work if it's like music or, video or something like that. Okay, so there's this idea of like, free for you to use, right? So you can read it, you can view it, listen to it, you can mail it to yourself, to your other friends or whatever, right? That's, kind of small scale. It's more for your own personal use. That's probably not much of a problem for that. And then there's like, you can also do something like what I'm doing right now. Maybe I'm using it to teach in class or something, right? So that's considered like fair use, okay? And then public domain, meaning no rights on it, and people can do kind of whatever they want, right? So free for anyone to use in any form, and you can kind of treat the information as your own, right? Usually things go into public domain is kind of like stuff that's been out there for a long time, right? So if it's something like fairly recent, like recent, artists and whatever, then it's not going to be in public domain usually. Usually for older stuff that becomes public domain. I forgot how many years we're talking about. Is it like about 80 years or something like that? I have to go back and check. But something that's been out there for quite a long time, then it will become public domain. Okay. All right, so there's a common idea here of this Creative Commons license. Okay, so when an author wants to give permission and right to share, use, build on the work that they've created, they'll work under this Creative Commons license. Okay, so it's pretty open. Like people can work together and do stuff with this work and whatnot. So you can like copy and distribute it without going back to the creator. Okay. But you want to give them credit, right? So one idea is like you want to do all of this, copy, distribute it, perform whatever. But the red part here, credit is given, right? As long as you do that, then you can kind of do these other things and it's not a problem. Okay. Now, the other thing they would probably restrict you to is you're not trying to resell it. So you're not essentially trying to take something that's free and then turn around and sell it to make a profit from it. So that's the other idea in terms of being non-commercial. Okay. Oops. And then the idea of being derivative work. So basically whatever the work is, you can't go in there and just kind of change a couple words in there and then kind of say, oh, this is my work now. Okay. So that's what they mean by no derivative work. Okay. And then the share alike. So if you kind of share, you can't change the license, right? So it starts off as this Creative Commons license. That's what it stays. Okay. So everyone kind of works under that. So it's essentially not allowing you to hijack the work and then do whatever you want with it, right? You can't like, change it a little bit and declare that it's yours. You can't take it and resell it. You can't take it and change the licensing terms on it. And then, like I said, the main part at the top is you make sure you want to give credit to the creator of this work. Okay, so those are the 4 areas that you want to make note of for the Creative Commons license. Okay, so this just talks about what is generally copyrighted material and what is not copyrighted material, right? Probably this one, a lot from when you do your research papers and whatnot, right? Stick to the facts, right? So, so this it's not going to be copyrighted, okay? Your opinion is not copyrighted, so you can put your opinion down. You have new ideas and you have old ideas, okay? So you look at this for your copyrighted, and then copyright material, you can use it for nonprofit instances, and you want to get permission from the creator of the work, and you want to give credit to the creator of the work. Okay, I think that's kind of just like good manners, I guess, right? You don't want to just like take people's work and do stuff without giving them credit, right? And you do want to check with them, and then give them you probably negotiate with them depending on what you want to do with the work, right? So you want to make sure you have that permission. Okay. This probably comes through a lot if you guys are ever involved with selling stuff on Amazon. So if you ever sell stuff on Amazon, they have all these different things they're scanning all the time. When you kind of get set up, you kind of have to kind of show like, where did you get this design from? Did you get this, did you create this on your own? Did you establish a trademark on it. If they scan it and they find out that, you're using something that is very similar to what someone else is doing, then like you're kind of like kicked out and all kinds of stuff like that. So, these type of things, depending on the jurisdiction and whatnot, can be taken fairly seriously, right? Of course, sometimes the owners of these are also constantly scanning out there. They're looking all over the internet or whatever, and they see something out there that basically has been stolen from them, like they're all over you, right? So this is kind of another challenge or issue that's come out from us, from technology in the recent ages, recent time. Okay, so let me see. Yeah, some positive and negatives from IT. Like I said, they're talking about IT in general, but really we're kind of more talking about in recent times with like internet, social media, and just the current state of technology. So it's more, you would say, contemporary challenges of IT. Okay, IT has been around for a while. You're not really talking about some of the other stuff in the older days. It's just like a lot of stuff that is more contemporary. Okay, so we talked about crowdsourcing, talked about electronic payments. I kind of alluded to a little bit about digital currency, and intellectual property. We talk about it from the software standpoint, proprietary license, that'll be like Microsoft, the web. We also have open source. With the example I gave was Linux. We talked about the copyright, fair use, public domain, and Creative Commons. And so from a studying perspective, and you'll see more of this in the book, just try to understand what fits the criteria. Let's say, what are your 4 criteria for using something under Creative Commons, let's say. Okay, so those are areas to pay attention to. Okay, so I'm going to like pause here. I don't want to get into chapter 12 until next time. Again, I want to open it up. If anyone has any questions related to exam 2 coming up, you can either send it to me now. I can try to help you now, or you can send it to me email. Let me know. Okay, I'm not going to give you any extra credit or assignment homework for today. I think the main thing is all of you just like study and prepare for the exam 2 that's coming up. Okay, like I said, exam 2 is JavaScript. It's a little bit challenging for some of you that have not programmed before. So, just do your best to kind of take down examples and try to understand how different things work. And hopefully we can do well for the exam 2 on Wednesday. Okay. Does anybody have any questions, things I can answer about flowchart, pseudocode, JavaScript? That's going to be essentially what exam 2 is all about.
Professor, will on-click and buttons be included in exam 2 as well from JavaScript?
Yes, it is. Okay. So when I gave those examples, like, when you do the on-click, just like when I did with the js.dl, we have the alert box popping up stuff. What you had to have done for your assignments, all of that is valid for the exam.
Understood. Thank you.
Okay. Any other questions related to exam 2? Okay. So the array function, where's that sample exam at? Let me see if I can get that. Where's the array? All right. All right, so let me, let me take a look at a couple of these arrays here. Okay. Okay, so this one, all right, so this is fine, right? So I did cars and I said this is a new array. Okay, so what's a valid way of accessing a value on there? Okay. So what's wrong with cars 9? Remember, I start off with 0, right? So actually cars 9 doesn't exist. There is no cars 9. Okay, so that's why this is not valid. Well, I can't do a 7.5, right? So that's not valid. And by the same token, cars 10 is also not valid. So that's why car 0 is a valid way to access an element. So whatever is inside of that, okay? Now, it doesn't really give any more than just this. So could be nothing, right? Maybe I didn't stick anything in there, right? But out of the 4 that you're given, this is the one that is the most valid, okay? So now we have another array here. We have an array and you initialize it with these variables, the big bad wolf, okay? So use a function to display the number of elements that my array contains, okay? So the key part here is dot length, okay? And you remember we did some for loops that, basically iterated through the array. And for you to do that, you have to know the length of the array, right? So this dot length is pretty important, right? So if you want to show how many elements you have in the array, this is it, right? So you do alert, and then you say my array dot length, right? And like I said, this is something that we used pretty often in the examples in terms of your for loop, okay? All right, so change the value of the last 2 elements. No, so the length of this array is 4, okay? There's 4 elements in this, 1, 2, 3, 4. Okay, but if I want to refer to each of the elements in the array, it's 0, 1, 2, 3. Okay, so because the addressing of the boxes start off at 0, the last number is always going to be 1 less than the length of the array. Okay, so the length of the array is 4, and the last element is 3. Okay, because you start off with 0. Okay.
I have a question about that, Professor.
Yes.
We aren't expected to just simply go back into the variable and change the last 2 into red and balloon. That's not what it's saying.
Okay, hold on a second. I'm reading this question here. So change the value of the last 2 elements with the value red and balloon. Okay, so this is just like an assignment, right? So the fact that I said my array 2, right? That's just me almost like saying variable ABC, right? And I'm assigning a value to it. So equals to red, right? So all I'm doing is taking that address spot 2 for my array and setting it to red. Okay, and then same thing for my array address 3, right? I'm setting that equals to balloon. Okay, does that make sense?
Yes, got it. Thank you.
Okay, so once you identify the address, right? I call the addresses like 0, 1, 2, 3, right? That's the address within the array, right? That's the box within the array. You treat it as a variable, just like any other variable, right? So, text, sample, right, equals to red. It's the same thing, right? It's just a variable at that point. Once you figured out which element in the array that you're working with, in this case, it's 2, and then in this case, it's 3. Okay. So use a loop to display each element of the array from 0 to the n. Okay. So again, remember from the for loop, my array dot length. This is really important, right? So you have the length of the array, and then you start off with your for loop. You initialize it to be 0 because the array starts at 0, right? So it's going to keep on checking, am I less than the length of the array? Because remember, I said the maximum array address is going to be 1 less than the length of the array, okay? And then you're going to say x equals to x plus 1, just like any other for loop. And then you would do the alert, and you would just display my array. and then the element within the array. So it's going to go 0, 1, 2, 3. Okay. So I hope that all just made sense there, and hopefully that gives you a clear idea of how to work with arrays. Okay. Cool. Any other questions I can answer for you? Yeah, so after it does the alert, just like any of the for loops, it will come up to here where it says x equals to x plus 1. Okay, so the first time, so this, you should remember this, when you do the exam, we're going to ask you to trace through some code, right? And when you trace through the for loop, you always say it starts off at something, right? So in this case, we're starting off with 0. Right? X equals to 0, it's coming through. Once you get done at the end here, it's going to execute this part, which is x equals to x plus 1, right? Which means 0 plus 1 equals to 1, right? And so on and so forth. It's going to keep on looping through. So essentially, after this alert, right? But remember, the alert itself is not incrementing it. What's incrementing it is it gets to this curly bracket here, and then it comes back over to here and says x equals to x plus 1, and then it processes everything in here again. Okay, so that's how for loops work. Okay, any other questions while I'm on the line here? Okay, so look, like I said, I'm checking my emails on a fairly regular basis. If there's other questions you have relative to what you need to understand for the exam, just send me an email and I'll try to get back to you as soon as I can. And good luck on the exam. Like I said, sign on to the WebEx, put your video on, and it'll be just like last time. Hopefully it will go smooth, and good luck with everything. Okay. All right. Have a good night.
You too, Professor. Thank you.
Thank you.